So it's my pleasure to welcome and introduce Dr. Manzoor Qadir, the Deputy Director of the United Nations University Institute for Water, Environment and Health. He has a background of many years broadly in the field of agricultural water management, and he's currently at the UNU, but previously he was at the International Center for Agricultural Research in the Dry Areas, also at the International Water Management Institute. He was also visiting professor in Germany and also professor in Pakistan. And he works in the area of unconventional water resources, sustainable development goals, climate change adaptation, and he's going to take about 45 minutes today to talk a little bit about some of the work that he's involved in. So thank you again for taking the time to come and speak with us.
Thank you very much.
Okay.
Thank you very much, Jan, for the kind invitation. And thank you very much for all of you for your interest in this seminar. So today I discovered another thing, that if you drive from Toronto to Montreal, you can perhaps arrive earlier if you want to fly. That might be a different thing. And I narrowly actually missed this opportunity. I just arrived, I think, 15, 20 minutes before. I should have been here around 9:30 a.m. So learning new things. Perhaps next time I should drive. So let's start with the topic. That's one of the areas where I work, unconventional water resources. And I'll start not from unconventional water resources with this slide, which I took from a 10-minute clip or a movie that was developed in 1940 by the British in the Indian subcontinent. They were basically developing this short movie on the cultural, socio-economic aspects of the communities. So where they didn't miss mentioning both water and fuel must be carefully conserved. So the discussions on water are not new, and they have been here in even the research and scientific arena for decades. So usually sometimes we understand and we anticipate that this might have been quite recent in the last maybe couple of decades when the large-scale water scarcity issues have started coming up. Climate change has actually impacted global water scarcity and water quality deterioration. But this has been long before that time. So before I dive into the topic, I'd like actually to share with you where we are at the moment, what type of water world we have. One key aspect is that the population densities and the water resources are unevenly distributed. Just give you one example. We are here in Canada, blessed with large freshwater resources. We are sitting on 20% of the global freshwater resources, and our population is just 0.5% of the globe. So now you can see there are pockets, particularly in the Middle East and North Africa region. Sub-Saharan Africa also is becoming water scarce, where there is the water scarcity is really increasing. And if you look at the right side of this slide, you will find a country like Canada might be on the left side, where the annual renewable water resources are more than 20,000 cubic meter per capita. Whereas there are countries in the Middle East and North Africa region where they have just less than 500 cubic meters per capita. Just to give you an idea, a country with 1,700 cubic meter per capita is considered, that country is at the margin of becoming water scarce in different types and categories. I'll not go into the details. And then in addition to water scarcity, the other associated element is water quality deterioration. That is also increasing, and ironically that is increasing in areas which are already characterized by water scarcity. And then climate change is further impacting the rainfall patterns and at the same time the overall distribution of water resources. And what we see is, and the scenario suggests that by the year 2030, 2/3 of the global population will face water scarcity. We are already actually approaching that stage. There are many countries, areas which are becoming more and more water scarce. And I'll not miss the opportunity to mention here, our study a couple of years ago has clearly demonstrated that after Middle East and North Africa region, sub-Saharan Africa is the next hotspot of increasing water scarcity. The reasons are that the water resources are not fully developed there, the population is on the increase. So it's a simple math equation. Even if we assume there is no impact of climate change, there is no other impact, the water resources are the same in a country, the population growth rate actually impacts that. So where we are, the conventional water resources like snowfall, rainfall, snow melt, easily accessible groundwater are not enough in many parts of the world to meet the growing needs of the population. So the impacts are that we are running out of water. There are multi-dimensional impacts. There is water-related migration has already actually started in different parts of the world. People just move where the water actually is moving. And on the other hand, I just actually shared with you on the right side. These are the places on this planet. I took it during my stay in Syria, where this is a wastewater channel, untreated wastewater carrying channel, where these are small pumps the farmers close by have installed, and these pipes, they sometimes run half a kilometer from the water channel to their field. So that itself shows that how much water scarcity in that area is, and the farmers are desperate to use any type of water which is available for irrigation. So what type of water would we need where there is a large scale water scarcity? So we will have to think beyond the conventional water resources, and here comes the critical input of unconventional water resources, which are basically the topic of today's discussion in focus. And they can't eliminate water scarcity, but they can help minimize the gap between water demand and supply. I'll just like to share with you some of the examples, and I'll just touch upon on some of the examples because covering all the different types of water, unconventional water resources might be actually beyond the scope of this lecture as well. So there are opportunities to harvest water from air on the ground, and I'd like to share with you 3 contrasting examples. One, harvesting water from fog. Although it looks that there might be just tiny drops, but if the strategies are right, if those nets are placed in the right direction, there are very reasonable volumes of water which can be harvested and can be used by the local communities. Cloud seeding, weather modification is also becoming critically important. More than 50 countries currently are using this technology to increase rain enhancement. And then the third category is harvesting water on the ground. I'm talking about that type of water which comes through small amounts of rainfall. It just goes back to the environment through evaporation. If we are able to capture that water, we can make some beneficial use of it. We can also develop new water in the form of desalinated water. And while there is growing water scarcity, we are using water and we are releasing wastewater as well. So there are opportunities in reusing municipal wastewater, agriculture drainage water, and the third category is ballast water, which is becoming quite important, and it is being recently considered as a potential water resource, particularly in areas which are close to the oceans and where there is a lot of ship traffic. I'll expand on them later. So all these type of unconventional water resources are connected with different sustainable development goals, which I'll talk later on that. So let's try to unpack different types of unconventional water resources. As I mentioned, I won't be able to address all of them, but I'll try my best to consider as much as or expand as much as I can. So the first one is harvesting water from fog and dew. So there are opportunities, and there are specific areas where the fog days are enough to capture water. Those range between 60 to 360 days, very specific locations. And there are specialized now nets. The communities used to develop use those classical nets, but now industry, private sector has involved. There's much improvement in capturing fog water, and dew water is also being collected. And although, as I mentioned, these are tiny drops of water, but they really contribute to, they won't be sufficient to grow agricultural crops, but they are sufficient to meet the local needs of the communities. I'm not sure how many of you have seen Avatar. It's a 2009 movie where there is one scene, if you might have captured, that an indigenous woman drinks water from the leaf. So just to share with you that these type of concepts are not brand new concepts. We are basically refining them, making them in a way that those could help benefit the local communities where they are. And accordingly, the interest in research arena has also increased over time. Look at what has been done in the arena of fog water harvesting, fog water collection systems. So look at the 80s, there were hardly any publication on that. And look at the last decade, where more than 200 publications, scientific publications in international journals have been published on different aspects. So they just started from the technical aspects, how the nets can be improved, how the directions of those nets could make it possible. But now the studies are available which address the economic, the social aspects, the community aspects, the gender aspects, and those have clearly demonstrated that by incorporating those aspects, these type of opportunities can become more sustainable. So that's where we are. There are areas where the fog events are quite frequent. There is a fog intensity to a level which can help capture the fog water, and then there are specific type of winds or locations which are helpful. So in a nutshell, there are areas where we can intercept fog, like dry mountainous areas, some coastal areas. And the additional advantage of this type of intervention is that it's a green technology. There's no energy required. So once you install the nets, and it works actually automatically. So the water is collected through the droplets of these meshes or nets, and then there is a gutter type of system where the water actually flows through, and it's stored, and then the communities have their own system of collecting and using it. And here are some of the examples where it's shown that it's being not practiced just at one place. There are so many places. And the interesting aspect is that if we just look at the water element of fog water collection, that is very important. But if we look at how other benefits join through implementing fog water collection systems, then it becomes more integrated approach. Why I'm saying this, the world's largest fog water collection project for years is being implemented in Morocco. And what they did, the women and the girls were traveling far distances, 3-4 hours a day, just to fetch water from far distances. So they installed these fog water collection systems, and now they are collecting water which is sufficient for the local communities. The girls are back in school. The women have established their cottage industry, so they are doing household things. The livelihood has improved. So if sometimes we just look at the water element of water, we just see how many actually dollars or cents per cubic meter or per liter, but there are other associated benefits which are usually ignored when we do these type of analysis, that what type of other benefits are associated. So I just thought I should flag some of the benefits of this type of intervention. Moving on to cloud seeding or rain enhancement. This has also been in practice for years in different countries for different purposes. The Russians are use it for in those areas where there are large hails storms, and what they want to do is they can break down those actually hail particles before they reach the ground, that they can minimize the loss on the agricultural crops. Countries like UAE are at the forefront of implementing weather modification technologies to increase the rainfall. And you might have read in one of the news that somebody also wrote during these recent floods in UAE, that might be the result of rain enhancement. We don't know about that, but at the moment these things are being investigated. The key reason is or the key principle behind this rain enhancement is the rainfall that reaches on the ground is just a small part of the overall rainfall or the overall water which is embedded in clouds. So if we could increase, and then this is replenished through a natural system. So if we could increase a bit by shooting certain substances like silver iodide, and I'll not like to go into the details of the technology, the rainfall could be enhanced. And scientific evidence has demonstrated that rainfall up to 20% can be enhanced by adopting different types of rain enhancement technologies through cloud seeding. So here are some examples of cloud seeding technologies, like we can shoot into the clouds through the plane or from the ground. So there are different actually options. 5 of them I have actually added: cloud-based aircrafts or rockets or cloud top aircraft. So ground generators or direct aircraft cloud penetration. So there are different types of interventions which in the end help improve the rainfall in a specific area. So there are actually specific conditions. Not every place one can enhance rainfall through these type of interventions. So there are specific areas, there are specific type of clouds. So there is now a growing science which they call physics of cloud seeding, and they are working on these dimensions, that what could be the right angle of shooting the cloud, what type of clouds are important, to which height they are important. So all these aspects are under heavy actually research, and countries like UAE and the UN entity, World Meteorological Organization, they are putting a lot of resources in understanding better this type of technology and implementing it on larger scale. I also mentioned micro catchment rainwater harvesting systems by saying that there is an amount of rainfall which is too small to stay on the ground unless it is captured. And that's where if we could make some type of arrangement on the ground, some type of small structures which could actually get hold of that rainfall, that could be used for beneficial purposes. At the same time, that type of rainfall could be captured as rooftop rainwater harvesting. You might have seen in some areas people collect water from the rooftop, and that is being used for different purposes. And then there are on-farm systems as well, like this one. If you so like on the right side, so if you do these type of contours and with the sloping land, so the rainfall actually comes, it stays there, and then some type of shrubs and species like that could be grown, and then the local farmers or the local area people can use this for livestock watering, for even small remnant farming as well. There are different type of structures for micro catchment rainwater harvesting depending on the landscape, weather, rainfall, topography of the area, and in some cases if the rainfall at certain stages or the part of the season is enough to grow a crop, those crops can be grown in certain type of strips as well. So it used to be quite a labor intensive option, because the reason was that they were small farmers, they were doing these type of interventions, and that was becoming quite laborious. But more recently there are now mechanized systems, those have been developed, and those could do these type of structures very fast, and this is one of the examples, and that's the equipment which is used, which is basically run by a tractor. So moving on to the water from air, capturing water from the air and on the ground. Now, how we can develop new water? How can we develop new water which is climate independent as well? Climate does not impact this type of water, which ensures that there is an uninterrupted supply of water, and that's where desalinated water comes in. At the moment, there are more than 18,000 desalinated plants around the world, and they are producing about 35 billion cubic meters. I'm sure all of you have the water background. I need not to explain that a cubic meter is equal to 1,000 liters. But just to give you an idea, sometimes in literature you might have read billion cubic meters or kilometer cube, they both are the same. And just to give you the idea, sometimes we talk about certain numbers, but still it's difficult to grasp what type of volume we are talking about. Globally, the volume of desalinated water which is currently produced is half of the volume that annually flows through Niagara Falls. So just to relate and just to visualize how large the volume that is being produced as desalinated water. And the desalination is increasing. There are more and more desalinated plants all over the world being constructed, have been commissioned in different parts of the world. So here there is a trade-off as well. Currently the desalination is pretty much concentrated in specific countries. Middle East and North Africa region, on the one hand it's one of the most, this is the most water scarce region currently on this planet, but at the same time they have about half of the desalination capacity at the moment. And just 4 countries, Saudi Arabia, Kuwait, Qatar and UAE, they are producing 1/3 of the global desalinated water. they are oil rich and they can afford that. And that actually brings me to the next point, that this, although desalination is very attractive, it's still being done in high income and upper middle income countries. And low income countries, there's absolutely nothing is happening on this arena. And the other countries I did mention who are doing quite reasonable scale of desalinated water are China, USA, and Spain. So let's move on to reusing water, how we can do that. So I'll start with municipal wastewater. We did a study which demonstrated that globally we produce about 380 billion cubic meters. Just go back to the desalinated water. Desalinated water is half of the volume that flows through Niagara Falls. This one is 5 times the volume of Niagara Falls. So it is the ratio between desalinated water, and if we capture all the municipal wastewater, treat it, reuse it, this is 1 to 10 ratio between them. Just to give you an idea the type of volume which I'm talking about. And this volume is set to increase because there is more urbanization, population increase, high living standards, and they will contribute to the increased volumes of these municipal wastewater. And our estimates suggest that by the year 2030 we will be having 470, and by 2050 we will have 574 billion cubic meters of water. And since Asia is the largest global region, they are producing the large volumes of wastewater. So if we capture all the wastewater, treat it and reuse it, there are 4 major uses which are already being held, which I usually call 4 A's: agriculture, aquaculture, agroforestry systems, and aquifer recharge. And there are other uses as well in industry. But if we capture all that water, and if we just dedicate this water for irrigation, that can meet the irrigation needs of about 42 million hectares. Just to give you an idea, this is about 15% of the global irrigated area, and it's really vital in those areas which are water scarce. So this wastewater is not only the source of water, this is one element, but it's a rich source of nutrients as well. We did a study, and we quantified that the nutrients which are embedded in municipal wastewater are in the range of 26 teragrams. So teragrams is basically 1 teragram is equal to 1 million metric ton or 1 billion kilograms. So again, I usually try to put things into more perspective just for better understanding and visualizing. So the closest example I could find was the Empire State Building. So in terms of mass, it's equal to 70 times the mass of Empire State Building. So if we capture all those nutrients, the benefits we will get is that this can offset 13% of the global nutrient demand. At the same time, it can generate 14 billion US dollars. And just leaving aside those benefits, those monetary benefits, savings on fertilizer, there is a critical benefit by capturing all the nutrients and not releasing these type of untreated wastewater or nutrients into the water streams or into the lakes. We basically eliminate or minimize eutrophication, which is creating a lot of issues when we talk about water quality deterioration. So wastewater doesn't stop at the nutrient level, it's also a rich source of energy. And I'm not sure how many of you are familiar with this energy equation? So basically, it can be the waste from wastewater can be converted into methane-rich biogas via anaerobic digestion. And now most of the wastewater treatment plants, particularly in the advanced countries, they are basically being powered by this energy. And just to bring into this perspective, this energy is enough to use within the wastewater treatment systems to make them energy neutral. In some cases, there are energy positive wastewater treatment plants as well. But if we don't use that there, again, for the perspective, this energy is enough to meet the energy needs of 158 million households, or about half billion population. So again, it's about 1/16 of the global population need can be met by harvesting or by extracting or by utilizing the energy from there. And again, if the wastewater volume is increasing, nutrients embedded in that are also increasing, energy will increase, more and more benefits in terms of resource recovery and reuse will be materialized. And the next one is ballast water. Just before entering into this unconventional water resources arena, I was also not aware of what is actually ballast water. So it's basically the water. You might know that water is held at the base of all these ships and containers which carry the trade, because that water or heavy mass keeps those ships flowing on the sea. Otherwise they may tilt, and that's why there are, in some cases, those are imbalances, those happen as well. So the global trade, 80% of the global trade is happening through sea. And before that, what used to happen was that the ships will come to the port, they will release the ballast water, and then they will fill that again when they are leaving. The problem with that is that they introduce invasive species from one area to the other, and that was creating a lot of issues for the not only for the aquatic life, for the overall you can say quality of the oceans as well. So back in 2004, there was a convention which was agreed upon all the UN member states that this water should be treated and then released. But it became in effect in 2017, and now it's being implemented. All the ships now which are floating on the sea, they are required to release that water before they need to treat that water before they release either to sea or to anywhere else. And there are specific requirements, water quality requirements, that they need actually to meet with that. So in order to meet those requirements, the quality of water that is released is good enough for specific purposes. That's not good enough for drinking purposes, but that's good enough to make maybe road plantings, irrigation, golf course irrigation, some crops irrigation, and stuff like that. So that water, instead of just putting it back into the sea, if can move to those coastal areas, can contribute to some extent to the water supply system. And their estimates say that it's about 10 billion cubic meters in all that. So that's the convention I talked about, and it's still not happening everywhere. There are still older ships which they have been given some years to rectify that convention and to implement those plans. But all the new ships, by default, they are built in a way that either they have on the ship treatment systems, or there will be on the coast treatment systems, so they can't actually avoid disposal without treatment. So I didn't actually go for the reuse of agricultural drainage water. I thought it might be actually good at this stage to share some of the trade-offs. While these type of water resources are in the arena, there is nothing actually something which is just came up maybe last year, a year before. They have been here around us, but the issue is their potential has not been captured. We are far from capturing its potential. And what are actually the trade-offs behind that? And that's I would like actually to expand for a few minutes. So there are political, policy and institutional aspects. Still there is a lack of political commitment to harness the potential of unconventional water resources. I give you the example of municipal wastewater. Currently we have about half of the wastewater which is released to the environment untreated, and that's that's happening in those areas which are water scarce. So the countries are not collecting, they are not using it, because the politicians, they think that perhaps this is happening, the wastewater released and that may be dumped to a close by freshwater body, the quality is deteriorating, nobody cares. The politicians think that instead of investing, putting a wastewater treatment plant close by city, it's more attractive to build a road or to build a big bridge to show to the people that is visually seen, and that's why it's getting less attention. I'm just giving you one example about that. And in some cases the policies either are absent or they are there but they are not being implemented. Morocco has the largest practical, operational and efficient in demonstration fog water collection system project. But if you look at the water policy of the country, they don't even talk about fog water collection. So that shows that these are type of individual project based intellectual interventions which have not been taken up in the public policy arena. And the third, equally important, is wherever that's happening, the institutions are not yet ready about that. There are very fragmented arrangements in terms of the implementation of unconventional water resources. There are overlapping responsibilities. Someone thinks, okay, this is the responsibility of this institution or this institution. So still there is a lack of clarity about the institutional responsibilities, and that's where it's very important, because when I was mentioning fog water collection systems, local institutions have key importance, because those are the institutions which help link the local communities and can provide the technical backstopping if something happens with those type of projects. And if they are not aware of, they are not fully trained of, and they are not engaged into this type of interventions, then there is always a kind of implication where these systems might not become more sustainable over time, and they may break down at some stage. The other aspect is the capacity. On one hand, we see there is a lot of potential. On the other hand, we see the countries where there is really a great need to implement these type of interventions, they lack in human capacity in implementing these type of projects. Climate uncertainty is also an issue, particularly in interventions like rainwater harvesting systems on the ground, because those need to be developed in a way that they can capture water. But if just one flood comes in and then nothing happens, then they might not be as sustainable as they are anticipated. So climate change is also impacting in some cases the unconventional water resources. And then there are community and gender related challenges as well. As I mentioned, those type of community-based approaches like fog water collection systems, like micro catchment rainwater harvesting systems, if the communities are not engaged, if they do not have the ownership, and we have seen in those countries where somebody just came in, just installed either micro catchment rainwater harvesting systems or fog water collection systems, the project ran very successfully, and as soon as the people left, the project just went down because there was no local ownership, there was no local training of the people. Where those projects like Morocco, the local communities are fully trained, they have full ownership. There is this very strong gender mainstreaming component embedded in that project, because the women and the girls are doing, because they see the benefit of getting that water next to their door rather than traveling 3 hours, 4 hours and getting that water. And then they see the benefits of health has been improved. These are documented benefits. The girls are back into the school, and the women are earning money while they are staying home, and they are doing some cottage industry work like that. So it's critically important to engage the communities and ensure that women and girls are integrated into that type of intervention if we want to make a community-based project related to water sustainable and efficient. And then there are environmental and health traits as well. Like on one hand, we say half of the global wastewater is untreated. The countries, apparently, the politicians think that they are saving because they are not investing in wastewater treatment. But on the other hand, public is paying for that, because the studies have very clearly demonstrated the areas where untreated wastewater is used, the communities are spending about 70% more on health expenses compared to those areas where the water quality or fresh water is used. And so government is not spending indirectly, the public is spending, and on top of that there are health implications, environmental implications. We are basically triggering the water quality deterioration equation, because we are releasing that untreated wastewater into the freshwater bodies. We are expediting the journey towards water quality deterioration, which is just unfortunate. The other thing is about desalination. On one hand, desalinated water is an excellent opportunity for us to get drinking water quality potable water. But on the other hand, it also releases brine. And till now, the industry is just pushing the brine back into the city, but into the sea. But now there are studies which have very clearly demonstrated those localized areas are becoming hotspot of challenges with regard to aquatic life. And so on one hand, there is a benefit. On the other hand, if we don't manage brine effectively and efficiently, basically we are in a catch-22 type of situation. And there are economic aspects. I already touched upon that usually we just look at the water cost of just that, how much money we are spending on the water. We ignore the other benefits. We ignore the other costs of alternate sources of water. So that's where, if we do a comprehensive economic analysis, then several of these unconventional water resources become more relevant and more practical and important in the overall equation of the water resources in a specific area, particularly those areas where there are issues with regard to the community-based interventions. And so in some cases there is a need to provide some initial subsidies or soft loans to the communities to start the implementation of that type of project. When it goes, then they can see the benefit, and they can put the money back into the system as well. So I'll stop here, and I'm not sure when I started, but I try to remain within 45 minutes. Thank you very much for your attention.